to nobody.
Welcome back to Two Nobodies, everyone. Rupesh is here again. You know, there are a lot of things happening right now in South America, particularly Brazil. The last 4 years have been not the greatest time for the Amazon rainforest, you know, with Bolsonaro as president in that administration and a great amount of deforestation happening in the region. Well, there's a new president there, Lula, and there seems to be a commitment and a pledge to restoring or at least reducing the amount of deforestation and hopefully restoring some of the Amazon rainforest. It's a fascinating time right now, especially politically. You see the uprising that's happening, some of that sort of, the rioting that's happening at the Capitol there, similar to what happened, January 6th in the United States. But what I want to focus on today is the Amazon rainforest and what's actually happening there and what level of destruction is going on. What does that mean for climate? What does that mean for environmental systems? And I have a fantastic guest here, Chris Boulton, a research fellow from the University of Exeter who works at the Global Systems Institute. Chris, thanks so much for joining us here on Two Nobodies. Appreciate having you.
Oh, yeah, no, thank you for reaching out. Yeah, it's great to be able to talk to people like this. So.
Yeah, for sure. You're at the University of Exeter. I've been to the UK a few times, but I've never been that part of the UK. So tell me what life is like in Exeter.
So I'm actually a really local guy. So I was born like 20 miles away from Exeter. So I've basically grown up in the area like 33 years.
Wow. Yeah.
It's down in like the southwest of England, like on that kind of boot that you have. So we're a bit out of the way, but we're getting, since I've been here, we've got the universities put a lot of investment in, and we've had the Met Office move down to Exeter as well. So I think we're kind of slowly linking ourselves like properly to the rest of the country at least. So I've seen a lot of growth in like industry and stuff, and certainly research from my point of view coming out of Exeter. So.
And it's right off the water too, right? It looks very beautiful, and I was looking at images of it yesterday.
Yeah. So there's beaches to the north and the south. So and also we've got Dartmoor as well, like a really big national park. And I think, from an international point of view, I guess like Sherlock Holmes has had some stories and stuff on Dartmoor, so you might know it from that. But yeah, that's a really beautiful place as well. So yeah, it's got a bit of everything.
Is there a lot of growth happening in Exeter, or are people very protective of that sort of thing? Because I imagine with a beautiful place like that, people are always concerned about growth, right?
Yeah, so I guess the main thing would be, like student accommodation and things as the university's growing out. At least that's the main thing I've seen recently. But yeah, there's like, shopping developments and stuff, but they are keeping those green areas nice and pristine as well. So you haven't got to go too far to get to nature and stuff. So it's really nice.
Yeah. Well, I hope one day I can make my way down there. It looks wonderful. Your story, as far as I think you're a mathematician, or I think you went to math, right? Is that sort of your base foundation, I guess? Or?
Originally, yeah. So when I was a young'un, I was really good at maths, and I was one of the only people who actually liked it. And if you like something like maths, it's really good to lean heavily into that, because you get quite a head start on other people who hate it. So yeah, my undergrad was in mathematics, and you suddenly get to a point where you realise you need to do something with that maths, and it's not just all like numbers and adding things together. There needs to be a reason why you're doing it. And so by the time I got to my PhD kind of age, that was there was this opportunity where, moving into the geography department with a background in maths gives kind of nice, a nice reason to move across and apply your maths to something that's, useful for people to actually see like results from, and, rather than just, doing accountancy or something like that, So yeah, that's how I got into kind of climate science, I guess.
So climate science in particular, was that sort of the first entry into like the geography environmental stream, or were you focused on
Yeah,
something else before that?
yeah. It's definitely so. Like I've got a kind of lean towards statistics as well, and
Hmm.
um, yeah, I mean, with the Met Office there, like the university was just starting to bring out these kind of mathematics with something degrees, and one of them was
Hmm.
climate science that made the link to the Met Office because they were trying to establish their connections, and I didn't actually take that course, but that was then in the back of my mind for then jumping on to doing PhD. So yeah, it was just straight from pure maths into climate science basically, and yeah, here I am.
Yeah. And so the connection, or I guess the application of mathematics into climate, I don't know if that's so obvious for people. So what is, how do those two kind of relate, or how do you apply the field of mathematics in climate?
Sure. So I guess the main thing is that people or climate scientists, they're interested in what's going to happen in the future, so they have to
Hmm.
model the basically the Earth
Mm-hmm.
and see what's going to happen when you do different things to it. And the only way you can approximate what's going to happen based on the processes you apply to that fake Earth basically is, putting loads of equations down and seeing
Mm.
how the numbers come out of those equations. So it's the same way as like you have a weather forecast where
Right.
you run these big supercomputers and they track what the particles in the air are doing.
Mm.
Climate models work in exactly the same way, except rather than just looking at what's happening every minute or second or whatever, they're looking at, daily or monthly things that are happening, and they aggregate that over a longer time period. So it's basically this idea that everything that's modeled comes from equations, and if you can understand how equations work, then you're quite a big step into, getting into this kind of climate modeling kind of area. The stuff I do isn't necessarily linked to those kind of models, but I'm sure we'll talk about it later. But I mentioned statistics before, and
Mm-hmm.
what I do is take the output from those models and look for statistical changes in the properties of the things that are coming out, and that
Mm.
kind of tells us something about how those things are changing that you don't necessarily just see from the output of the models on their own. So yeah, that's where I come in, but I'm pretty sure we'll talk about that later. So
Well, no, absolutely. I do want to talk about that. So then, getting into the focus on climate in particular, when does that start? Does that happen right away for you? And I
um,
guess what was the sort of compelling reason for wanting to focus on that particular area?
yeah, so that was that came out of when I was finishing my my mathematics degree. I was looking for certain PhDs that were being offered at the university, and
Mm.
um, my colleague, I guess, or supervisor at the time, Tim Lenton, had this opportunity of looking for early warning signals of tipping points. So
Mm.
there's this concept in climate and other areas as well that you can see large sudden changes in systems just by pushing them and pushing them and pushing them, but not necessarily seeing anything beforehand, and then you might push something off a cliff basically, and you get
Mm.
this large change in the system when you didn't expect it before. So he'd been dabbling with this idea or this mathematical theory that you can pick up these changes in the system by looking for certain indicators of
Mm.
that happening beforehand. So that's where I came into it from there. He was in, we were interested in looking at certain climate systems, these large scale systems that govern what's happening in the climate system as a whole. And I did a summer placement at the Met Office, and they happened to be interested in what was happening in the Amazon and their models. So that led me to think, oh, well, let's start looking at the Amazon. This
Right.
was this was like maybe like 15 years ago now. So I've been kind of around the houses, and I've worked on lots of different other projects, but I guess the Amazon, because of that, it's kind of something that I keep coming back to. But that's not
Yeah.
to say I don't look at other systems as well. But yeah, that's kind of a lead in for my introduction to climate, I guess.
So with the climate tipping point, is applying mathematics, was that something that's not wasn't really there as far as like in terms of determining those indicators for when those climate systems start to tip over. Is
Uh-huh.
that a relatively novel area?
Yeah, so it comes from like a pure maths kind of theory where like you have these equations again. They
Mm-hmm.
might not necessarily describe anything, but you can kind of slowly change a parameter in them. So you might, you've got a dial and you might slowly dial this a certain direction, and you suddenly see a big change in what
Mm.
the output of that equation is showing. And that's when you have these equations, they have like equilibriums in them where, if you push a system slightly away from that, it will return to that equilibrium.
Mm.
Um, and like this parameter would change the stability of that, so it would make it weaker and weaker, and make it harder for that system to get back to that equilibrium, and eventually that equilibrium would disappear. So the whole concept of they call these like bifurcations in mathematics. So these bifurcations have been known for, well, probably centuries, but I
Mm.
think in the 80s someone came up with this idea of being able to see changes in like the time series, or the
Mm-hmm.
output from the equation, to see that you're approaching this without actually knowing that you're dialing that parameter as such. um, and so yeah, I guess around like around, yeah, like start of the century, I guess, like actually one of the colleagues now at Exeter noticed that in one of the Met Office climate models, that they could force the Amazon, or force the climate system, and the Amazon has this collapse in it, in their model at least.
Mm.
And so that made, that brought in, like a lot of attention of this idea that you could have these non-linear changes in the climate system as well.
Mm.
And so people started to think, well, where else could they be? And by the time they worked those out and I got to my PhD, it was starting to get to the point where, well, we could apply these indicators to those systems and see if they work. And certainly in some cases they do work, and you can see,
Yeah.
you can see an early warning that you're approaching these things. I guess the problem with that is that it's quite easy to do in models, because you can force the system to collapse and then see if you saw the early warnings. But in the real
Mm-hmm.
world, kind of don't want to force a system to see if it's going to collapse
Sure.
and go,
Yeah,
yeah, I
for
knew that was
sure.
going to happen. But so we're kind of, we're out on a ledge and we don't know where the actual the end of that ledge is at the moment. So we
Yeah.
have to use these indicators on real world systems without knowing what the outcome is, hopefully.
Yeah.
So
Yeah.
yeah, that's a quite an interesting concept. So
I wanna dive a little bit into maybe some of those climate tipping points that you folks are noticing, at least, that are very concerning, or you're seeing those maybe warning indicators kind of pop up. I don't know if you
mhm.
can comment on that, but before I mention that, just it's really interesting, just the application of mathematics in so many different fields. I was talking to somebody about the James Webb Space Telescope,
Right,
and he
yeah.
was saying how I was like, "Where is this thing?" And he's like, "Well, it's in this space where there's kind of essentially equal pull between the gravity of the Earth and the Sun." And I was like, "Well,
Yeah.
how do they figure that out?" He was like, "It was a mathematician, the Lagrange principle,"
Uh-huh.
and I was like, "This is incredible." So,
Yeah.
just the possibilities of what you can do with that field are
Yeah,
incredible. So
one thing I found with it is once you move away from it, there's a definite, like you just have your headlights on, and it's like, this is the only bit of maths I need to remember now, because that's all I use in my work. And if someone
yeah,
mentions something totally different, it's like I don't know what you're talking about, and then you have to go back.
right.
So yeah, you
Yeah,
really specialize once you move away, I think, and that's an interesting thing as well.
yeah. These what are you noticing as far as these climate systems and some of these tipping points from what your folks are researching? Like which systems are very concerning right now as far as and I don't even know, are there any systems that have kind of tipped over? Um, yeah.
Yeah, so that's an interesting question about whether they've already tipped. So I mean, my someone that works at the university, they recently had a paper out where they've done a big review of all the science of climate tipping points, and I think that came out a couple of months ago towards the end of the year, and they've obviously the easiest way to categorize which are the most alarming is how much warming would the planet need to be to probably tip them, so you can kind of rank them in that sort of way.
Yeah.
And so like some of the ones that perhaps are a bit worrying, maybe with like 1.5 degrees warming above pre-industrial, you see like kind of like like ice sheet melting and things like that. And those sort of things are going to change circulation patterns and have knock-on effects for other parts of the world. So you see things like that are potentially right round the corner, but a lot of this is based on models, and there's lots of factors when you model these things. It's what are we going to do over the next century, and how is the Earth going to react to that? So you have this model uncertainty of how the different models react to that thing that you're doing, and we also have uncertainty about ourselves, about what we're actually going to do as well. So I think a lot of this gets there's a lot of uncertainty in these different directions, so it's really hard to pin down like what is likely tomorrow or something. Obviously it's not going to happen literally tomorrow, but so I think from my point of view, I focused on the Amazon. I've also looked at the Atlantic meridional overturning circulation. So that's so that's an ocean circulation pattern that basically keeps us here in the UK warm, I guess, compared to the other latitudes. The same things on the same latitude. So it's this idea that you get kind of a current that goes up to the North Atlantic, and then you get this deep water formation that's like a conveyor belt. I don't know if you know the Day After Tomorrow film where everything turns to ice. So that is supposedly if the AMOC was going to collapse as a tipping point.
Okay.
So that, for example, is likely to be quite a long way away. But again, this is all based on models and things. But you said about things that have already tipped, and we had a conference a few months ago at the university about tipping points, and there was quite a social aspect to that, which is quite good because the idea of society and tipping points is coming in. And we learnt from colleagues in Brazil that perhaps there's already been a social tipping point in the Amazon. The idea that people are struggling with floods and droughts, and they're already being severely affected. And when I do my work, I'm just interested in the vegetation that's there and whether the trees are dying back. But there's like weather patterns and things that are happening that actually affect people's livelihoods, and they lose all their crops, or they lose their house and things, and perhaps to those people personally that is a tipping point, because so from a societal point of view, perhaps things like that have already reached tipping points, but from a from us saying, oh, climate science tipping points, perhaps we're not there yet. But, from people who are deeply dependent on those areas, perhaps they already have reached a tipping point. So, yeah, that's an interesting question.
I never thought about social tipping points because, I think when you think about a climate tipping point, it's like, it's so, it's just, the scope and scale of that is just unimaginable. The level of control that we have also on whether to reverse a tipping point or not, or restore it back to its original state, like whether that's even possible is maybe unknown, or whether what can be actually be done. But a social tipping point, at least my mind naturally thinks, well, sure, but maybe there's an ability to restore that, or it's just not as obvious, I suppose, for me. But yeah,
I guess like naively, you can obviously compensate people for having reached those social tipping points if they need if they need things in their life restored. But should we be actually focusing on the problem that's causing that as well? So I think they're quite entangled, and it's hard to pick apart those things. But yeah, from my point of view, I think that is important, as well as just looking at the climate as well. So.
Yeah. Do you also look at the interaction between different systems and how they could affect whether one tips or not? I guess.
Yeah, I mean, personally, I don't, but I
Yeah.
definitely know that researchers do.
Mm.
So there is like, this kind of, I guess they call them cascading tipping points.
Mm.
But, it might be the idea of, I talked about the ice sheets before, being
Yeah.
tipping points. They're going to change ocean circulation patterns. They might warm, um, certain latitudes that, have like boreal forests there, for example. So,
Mm-hmm.
you've got those northern latitude forests, and, they're getting a lot warmer compared to what they're used to. So, you might get a tipping point in those, and that might change circulation patterns as well. I mean, I said about the AMOC, that would be, that's probably a longer term thing, but if the AMOC were to collapse, that would change the rainfall that happened over the Amazon, for example.
Mm.
So, you know, the
Interesting.
so the Amazon might get um, less rainfall, but perhaps maybe like more sustained rainfall over the year. So,
Mm.
they would have to think. I don't know if plants think necessarily, but it would have to adapt to those changes in rainfall, and
Mm.
whether that would cause a tipping point or not, that's something that we're interested in as well. So, there are all these knock-on effects, and they're generally related to the circulation patterns that change, and that in turn changes, I guess naively, the temperature and the precipitation at that specific
Mm.
area, and then then you see if that climate system can live with that, or if not, then that's going to tip. So yeah, there's a lot of ideas of these cascading tipping points that are coming out recently as well.
I think there's a bit of a gap in communicating like those cascading temper points, right? Like somebody, someone living in North America hears about, I don't know, a climate system that's being affected so far away. They might not understand how really that affects them at
Sure.
home. But like if you kind of walk people through the way you just did on some of those interacting climate systems and how one can tip off the other,
Hmm.
it starts to get closer and closer to home, right?
Yeah, and I mean, just related to that anyway, like the Amazon is a massive store of carbon. That
Mm-hmm.
is carbon that isn't in the atmosphere, and if you were to
Mm-hmm.
have the dieback of this forest, then you're going to be releasing that carbon back into the
Oh goodness.
atmosphere. So
Yeah.
even without like another tipping point climate system, just the climate system as a whole, like that would have a global effect on itself without thinking about
Mm-hmm.
specific systems afterwards. So
Mm-hmm.
yeah.
It's just like the what we're dealing with here in Canada. I don't think people understand the amount of storage that the permafrost has, right?
Yeah, well, that's another one. Yeah.
And that is slowly, melting away, and large amounts of carbon are being released. So
Hmm.
I don't know, people, yeah, it's interesting.
Yeah.
The Amazon rainforest. Have you been there before?
I have not, no. So I'm one of those people that
Okay.
talks about it a lot without knowing what I'm talking about. So yeah, my partner has actually, but yeah, I haven't.
Okay.
So that's always a joke between us. That
Is that a place you want to go one day, or?
yeah, I think it'd be nice. I mean, I feel like perhaps I'd understand it even better if I went there, but
Mm.
I like to think that um, I don't know. Maybe I can go there as a when it's perfect and it's all back and we've saved it. I can go there as a little celebrationary trip. But yeah, it does
Yeah.
sound nice to go, I think.
Yeah, yeah. What is happening in the Amazon based on the research that you've done? What have you noticed?
Sure. So, would you like me to get technical here, or?
Well, let's. You can get technical. I might bring you back a little bit. So let's
Sure.
try.
So I guess like obviously I haven't been there, so that I talked about models earlier, but we're actually using real world data that's taken from satellites. So
Mm.
you can, the satellites that go over the world and they get remotely sensed data. So they basically send microwaves down and something gets beamed back up to them, and they,
Okay.
with some processing of data, you can tell things about the land that it's just picked up
Mm.
information about. So we used a product that's called vegetation optical depth, or VOD
Okay.
for short. So
Okay.
what that does is, very simply, it kind of picks up how much biomass of vegetation is in a specific grid point. So,
Mm.
it splits the world up into grid points, and so the satellite shines or flies over, and it it shines these microwaves down, it gets some information back about that specific location. And in this case, the product we used was this VOD that tells you, if that number's higher, then we know that there's a lot of biomass or tree or forest at that specific location.
So kind of like the density of the area as far as the
Yeah,
vegetation.
yeah,
Yeah.
exactly. It's quite strongly linked to the water content of the tree, so how much
Oh,
water they're
okay.
storing. So
Okay.
can kind of maybe be a measure of how healthy they are as well in a way,
Mm.
because if a tree's got enough water, then it's happy.
Mm.
Perhaps you might see it dip after a drought, for example. So because there's not enough water for the tree. So that same tree would be there, but it would have a lower VOD because it's got less water in it.
Okay.
And so these satellites go over and they scan a strip because they're flying over at a specific time, and the next day they might pick up the strip next to it.
Mm.
And so we can kind of aggregate this data up to like a monthly data set. So at this location at this time we had this much VOD, and so at each location you can get a kind of a time series of what the trees are doing. And so what we can do is we can do some pre-processing of the data, and we can say we're only interested in the Amazon basin, for example. So we draw a ring around the Amazon, and we're only interested in areas that have this much like broadleaf tree in them, or like the actual tree. So we've got another data set that tells us how many what fraction of that area is broadleaf trees. So we're really drilling into the rainforest of the Amazon with the places we're looking at, and so we've got a time series at each of these locations, and that's over like 6,000 locations. And so then what we do is we measure these indicators on each of those time series. So like I said, someone in the 80s came up with this concept of critical slowing down. So what happens is if a system is going through one of these kind of bifurcation things I was talking about earlier, where it's losing stability, it will take longer to recover from perturbations. So perturbation for the Amazon, for example, might be a drought that happened. So you can imagine like this VOD, the drought happens and this VOD goes down, and then it will slowly recover. Once the tree's happy, it will go back to the VOD value that it was before that drought. And so if you're approaching this bifurcation, you're losing stability of that that stable state or that equilibrium. So the idea is that if you force or perturb or cause a drought on that system, when it's weaker or when it's closer to bifurcating or closer to the tipping point, then it's going to take much longer to recover from that perturbation, because the restoring feedbacks of that system are much slower or much weaker. So you can imagine that for the Amazon you have these droughts that happen, but sometimes it rains more. Some days are drier, some days are wetter, some days are warmer, some days are colder. And so rather than having this idea that you're perturbing it to here and then it's coming back, the system's actually moving around like this.
Right.
And so rather than just being able to pick up that the system is taking longer to recover from perturbations as it's approaching a tipping point, we instead look at something called the lag 1 autocorrelation, which is...
Okay, you're going to have to explain that one.
I certainly will. So I mean, mathematically, you have a correlation where you measure two variables against each other and see how correlated they are.
Right.
So this autocorrelation is basically where you take our time series and you put that on one axis, and on the other axis you put what it was at the previous time step, so you're lagging it by 1.
Okay.
And the idea being that if you've got a higher correlation between these, then your system's slowing down because it's much similar than it was at the previous time point. If you've got a system that is very stable and you did this, you'd see a much lower correlation because there's not much interaction between what was happening in the previous time step, because when I said that you're coming back to that equilibrium or back to that stable state, you're kind of getting slower to get to it. So you can imagine that the previous time point is much more similar to the one that you're at today. and so you can kind of get that concept of slowing down. Whereas if it instantly got back to where it was, like, faster, then you're not going to see as much link between what happened the day before.
Sure. Okay.
So what we do is we measure this. Well, we call it AR1 for short, the lag long autocorrelation, but we measure that on a sliding window that we move along our time series. And you should see that if you're approaching a tipping point, then that indicator should go up over time because it's becoming more correlated, because it's slowing down essentially. And we also look at a change in variance on a sliding window as well. And that's simply because we use this ball in a well analogy generally. So if you've got a system that is very stable, you might have a well like this with a ball that kind of rolls around. As you start to dial that parameter I was talking about earlier up, it starts to shallow out, and so the ball takes longer to roll back to the middle. And also it can sample more of the area, so it's kind of that variance should go up because you've got more space to sample, and also the AR1 should go up because you're slowing down basically as you're coming back to the middle. And so we did this on each of the time series that we see, those over 6,000 in the Amazon, and in over 3/4 of them we did see a significant we saw an increase in this lag 1 autocorrelation basically, and particularly from like the early 2000s. So from the start of the century we start to see a really strong increase in the fact that this AR1's going up, which, as I said earlier, we don't we don't know where that ledge is that we're going to fall off because it's not a model, it's the real world, but that would indicate that we're approaching this tipping point. We generally call that like a loss of resilience in the system. So resilience being the ability for that system to get back to that equilibrium, or that ball to get back to the middle of that well. So we'd call that like a loss of resilience generally. So we don't we might not necessarily know what an Amazon tipping point might look like, but at the moment that resilience is being lost in the system as far as our results show. So so actually, without being to the Amazon, that's what I'm able to show.
Yeah. Okay. So so what are the consequences if we do see a reduced resilience in the Amazon?
So I guess from a resilience point of view, I was talking about those droughts earlier. So we've seen what people do call like 1 in 100 year drought events, but they happened in 2005 and 2010 and 2015ish. But the idea is that because we've seen a loss in resilience over that time, if we had a drought in 2005 and the forest recovered from that, if we had that same drought now, because it's got a lower resilience, it would take longer to recover from that drought. And so you can imagine because of that you've got a forest that's more degraded than it was a couple of decades ago. So that's kind of what we're talking about here, the idea of that forest to restore itself back to when it's healthy after an event that's happened. So that's kind of what we'd be talking about by saying a loss of resilience.
So practically, what do you think is actually happening on the ground with the vegetation that's contributing to this loss of resilience?
Sure. So I guess we've got like global climate change happening. So we have increasing temperatures and changes in rainfall that could happen because, again, these circulation patterns. There's this idea that if you warm up the northern hemisphere, then that moves something called the ITCZ on the world, which is like kind of like the trade winds that go across the equator. And if you warm the North Atlantic up, then there's these might go more north, and that would change the rain that happens over the Amazon, for example. So you have these global weather change patterns that are happening, which aren't helping the Amazon. And then you alluded to things in the introduction, this idea that you're seeing deforestation as well. That's generally happening on the east and the south where people live,
Mm-hmm.
and so the Amazon has a kind of water recycling network because it's a rainforest. So I think people call it the atmospheric river to be poetic, but it's this idea that the wind blows rainfall in from the Atlantic, and it rains down on the Amazon, and then it gets evaporated and the wind blows it further inland, and there can be this idea that the rainfall can recycle itself like up to 7 times as it goes more and more inland. And so if you're having deforestation on the edge, you're kind of breaking down that possibility of that happening. So you get the rainfall on the leaves that are then evaporating back up into the atmosphere, but if it falls onto like bare ground or soil, for example, it's much harder to get back into the atmosphere. So you kind of got these global patterns happening, but you're also breaking down the kind of
like the microclimate there.
Exactly. Yeah. So I've been saying that the Amazon's quite interesting because a lot of these climate systems that we look at are generally affected by global climate, but the Amazon's being attacked on 2 fronts basically. So there's both of these things going on and interacting with each other, which from a maths point of view I find quite interesting, but is also quite sad. But
because of the size of the Amazon rainforest, like you kind of spoke to this about the rain cycles that just happen within the Amazon naturally, and how that can be disrupted. Obviously, the way it's very clear from what you're talking about that other climate systems have an impact on the Amazon rainforest. But in terms of just what's happening locally, like if there is, do you know if there was some level of restoration, could it kind of build up that resiliency, or is that resiliency largely more dependent on other systems outside of what's happening in the Amazon? Does that make sense?
Yeah, so historically, the Amazon's been there for thousands of years, maybe tens of thousands, and people who know more about paleoclimate than me will probably tell me I'm wrong on that, but it's definitely, as far as I'm concerned, it's been there for a long time, like before we were here. And up until very recently it has been a carbon store, so it's been storing a carbon from the atmosphere, and there's research that came out a couple of years ago that suggests that the burning of trees from the deforestation and getting rid of those trees for the last few years has perhaps maybe been more of a carbon source than the storage that the Amazon's been taking in. So that balance is kind of changing ever so slightly. Yeah. So, but that is only just happening, and so I think that if you kind of stop that deforestation, then you're definitely going to gain that resilience, and that would start the Amazon to be a carbon store again, and so that's then going to help for the more global picture as well. So you have this knock-on effect that by helping the Amazon itself, then you can in turn help the other thing, and that's going to be a kind of nice feedback rather than the bad feedbacks that cause the tipping point. So I think, obviously we're at a time where with the political climate there is a chance to do something now, and I think that would be a good time to do it. But I feel confident that resilience could be gained back if the right actions are taken soon.
I don't know if this is sort of a cheap and lazy way of thinking about like a solution or how we approach this, but could it make sense at all, given again how you just described right now how important the Amazon rainforest is to overall global climate systems? It's always described as the lungs of the earth sort of thing, right? Should we as a global society really, if we can, like focus so much of our efforts on trying to restore the Amazon, and do we know if that would have a large impact on the way the other systems kind of feedback from that? Like, do you know what I mean? Like, like it's like we can't, like, I don't know what we could do about the ice sheets directly, right? Like as far
Yeah.
as restoring them, right?
Mm-hmm.
Maybe there are other systems that we can maybe have some control or influence on. I'm not sure, but the Amazon seems like one where we can potentially have a lot more human control over.
Yeah, yeah, and that's exactly what I meant when I said, it's being attacked on two fronts, and
Yeah.
so yeah, I mean, I haven't, I haven't ventured into the politics of things too much, but
Mm-hmm.
I guess you'd have problems about, perhaps people need that deforestation as part of their livelihood.
Yeah. Yeah.
Really they shouldn't, but how do you tell somebody that who, needs that kind of thing to happen?
Mm-hmm.
I mean, the politics have been on the side of doing that recently. So,
Mm-hmm. Mm-hmm.
I mean, I'm all the way over here in the UK, so I don't feel I can comment on the specifics of politics from other countries, but I can imagine some global effort would, go some way to helping that at least. But the intricacies of how that works, are probably I'd say above my pay grade as such. But
Right.
yeah, I can. In a perfect world, if that could happen, then that would be a really nice way to help combat climate change, I think. And
Mm-hmm.
in my in my starry-eyed view, like saving all the biodiversity as well that is in the Amazon, because it's not just about climate; it's about saving lots of species that live there as well. And you hear about all these animals that go extinct and things, and it'd be nice
Mm-hmm.
to also have that, and as well as a saving for the climate as well. So
For sure. I don't know if you heard recently there was the Montreal Biodiversity Conference
right.
that happened, and apparently there's $30 billion that came out of that to commit to biodiversity. And
Oh, cool.
my understanding is a good chunk of the money is going towards the Amazon. So,
Nice.
and then I
Yeah.
think I read also that Norway and Germany, they had specific funds to support the Amazon rainforest, but they had shut it down while Bolsonaro was president, and now they're looking to restore that fund.
Ah,
So
that's cool.
hopefully there is some good efforts and some good money flowing
Ah,
towards this.
there we
But
go. Yeah.
yeah, yeah. When you think about just like how to improve the situation and to quote unquote, I guess, like save the Amazon, I know that may not have been the focus of your research, but I don't know if you had personal thoughts that kind of gone through your mind, or if the work you're doing at the Climate Systems Institute is kind of looking at that. But what needs to happen, I guess.
Yeah. I guess. Yeah, I guess the main thing is to try and stop this deforestation, or at least have it controlled in some way to, you know, um, perhaps make it in certain areas if it needs to happen, but
Mm-hmm.
because that would be areas that are least affected. I mean, you have like it's not just the deforestation as well, but it's like the roads that cut through the Amazon and things that also
Mm-hmm.
affect this recycling network. So you get the idea that they might build a road through and then go part way into the Amazon to cut some trees back a lot deeper in than you actually expect that they're doing just on the outside. So
Mm-hmm.
trying to have a handle on those sort of things. I mean, obviously no deforestation at all would be great, and maybe like reforestation and trying to grow those trees back in those areas would be a really good step. But again, from like the politics point of view, I've got no concept of like the funding for that to happen. But
Right.
from a science point of view, that's the sort of thing that we should be looking at doing. So
Yeah, I was reading that Lula is actually, well, at least the commitment is that no deforestation by 2030.
mm-hmm.
So I don't know if that
Yeah.
if there'll be sort of a ramping down of that over time, but it looks like the politics are in favor of
Yeah.
hopefully restoring some of this. But I just don't know that, like, in the modeling you folks are doing, like, is there a certain timeline that you think there is for the Amazon? Again, it didn't sound, I guess, correct me if I'm wrong, we don't know if we're at a tipping point. Is that right? Or
So yeah, I guess I would phrase this as like an early warning signal that we're approaching it. So, I would
mm-hmm.
feel that there's still time to do something. And when I've done interviews and stuff, it's kind of been for like this message of hope in a way that this is some evidence that it's going to happen.
Mm-hmm.
And then there's kind of as I said before, with the climate modelling, we don't know what the future is going to look like. But, perhaps on the trajectory we're on without any intervention, you might start to think that something might happen towards the end of the century in the Amazon, but that's my personal viewpoint. So other people might think it's got more time and others less. And then the thing about the Amazon as well is that trees take a really long time to show changes that have happened. So, when we've modelled this and we forced it to a tipping point, you might see there might be decades before you actually see a loss of trees, but the trees are already in a place where it's unsustainable for them to survive. I'm extremely confident that that isn't the stage we're in at the moment, but just as a timeline point of view, the general consensus for the tipping point that would happen in the Amazon, you might suggest that once you've crossed that, that would take a few decades to be realised. And, without these kind of warning things, you might think, oh, it's fine, the Amazon's there, but it's not very healthy. And, you don't realise that without delving more into the kind of indicators like we do. So, in the future, just because the forest would be there, it doesn't necessarily mean that it's staying there. If you fix climate at the end of the century, you might see in 10 years' time the Amazon goes anyway, and you go, but it's there 10 years ago, and but it was already too late because you'd already crossed that tipping point and not realised it. So
when you just said like potentially maybe the end of the century. I mean, for us sort of small-minded humans, like that seems like a far away time, right? Like it doesn't. But especially when they're saying like some of these we could be approaching, this 1 point, like we're going to be higher than 1.5 degrees by that time. So it seems like, okay, well, if it's not until then, like we have a lot of time. But what you're also saying is that we're setting the groundwork for a lot of unsustainability here for that vegetation.
Sure. Yeah, so you have like I say, like those ones that are potentially sooner with the ice sheets, if you have the changes in their circulation patterns, that might push the Amazon towards tipping more. So it might not be that end of the century I was talking about, it might be a lot sooner. So we had a really I had like this interesting conversation with people at our tipping point conference, and how do you convey the message of an early warning signal, and saying, if we said to the Amazon, if we actually worked out like, well, the tipping point's going to be in 50 years, and if you tell policymakers that, they'll go, oh, I'll be retired by then, or dead, or something. But it's like, but no, the things you actually do today are going to affect that future 50 years. And so, how do you get that point across that, and that goes for climate in general as well. If you tell someone at 2100 the temperature's going to be like this, I mean, I've seen climate models go out to like 2500, and they say this is like what the world would look like in 2500, and generally we don't care about that far ahead. But so but perhaps if we are at that point in time where we might start to see the actual big changes that are happening in our lifetime. And I heard something from a comedian the other day saying that they were supposed to be at that perfect point in life where their parents had messed up the climate, and their children were going to be the ones to have to deal with it. But it turns out perhaps we're going to be the ones that have to deal with it because it's a lot sooner than we thought. So so it is it is on us now, and it's not trying to pass the buck to the people afterwards.
Yeah,
well, it shouldn't be anyway. We should be trying to do something, but
no. But what also comes to mind is, like you said, 50 years from now, people can't even think about that. And I think that's why you see, I don't know if you've noticed, so many companies, so many governments are saying net zero by like 2040 or 2050. Like so much of that to me is kind of past the buck, right? Like but I don't know if a lot of these companies or a lot of these governments really have. I'm being very general here, but it's an easy thing to say, hey, by 2040 or 50 we'll be net zero. It's not something you have to think about right now, right? Like
exactly. When should we start working on this? 2035. Sure.
Oh yeah, we'll have enough time, right?
Yeah, exactly. Yeah.
Yeah, it's a bit sad. You folks are also looking at something called positive tipping points,
We
which
are.
I hadn't heard about
Cool.
until I started looking at the work that you folks are doing. So tell folks about what the heck a positive tipping point is.
So, we're getting to a point where, we're seeing people actually really interested in the climate, and you see climate rallies and things happening in the world. And so, there's this concept that, Tim Lenton has kind of led on this at Exeter, but this idea of positive tipping points where, you can change things in society to make people behave in a more energy conscious way, perhaps. And so a really good example of this is like electric vehicles, for example. So, there's a whole structure about infrastructure and the price of batteries and things, but you can kind of, especially in Norway, you can kind of follow this through, and you get to a point where the actual price of electric vehicles is kind of on par with like petrol vehicles, and suddenly everyone's like, well, I'll go electric then. So you can imagine that as a tipping point, because you're getting to that point. You've been pushing the prices of electric vehicles down to a certain point where someone goes, yeah, I'm going to buy one, and then everybody buys them, and you get a tipping point, but in a positive way. And so us at Exeter at the moment are trying to, so we started to call them early warning signals, but I think we're now calling them early opportunity signals. So it's the idea that you use kind of the same methods. This idea that, perhaps your state is that people aren't energy conscious, very basically, or environmentally conscious, and you can degrade that state by making certain changes to, let's make electric vehicles cheaper or whatever, and that should, eventually tip people into deciding that they want to be on the other side of the fence and buy them. And so, we've got, we're looking at lots of interesting data at the moment, not just like climate data, but, data from what people are talking about on Twitter and car sales. One of our PhD students in the group is interested in like the movement towards like meat-free diets and whether that can be a positive tipping point. So it's all things like that. And so we're looking for the same kind of signals. So from my point of view, I have this crazy idea that socially you should be able to see the same signals, because like a perturbation in a system like that might be that like like a new electric vehicles come out or something, and so lots of people talk about that, and then the attention from that dies away, and you get back to a baseline attention, and then in a couple of months' time, if another electric vehicle comes out and people are really interested in that one, then the mentions of the topics of that or how people are talking, that'll take longer to return back. And it's exactly the same way as like the drought in the Amazon with the trees recovering. So it's a concept that definitely needs a lot more theory behind it. But naively, I can imagine that the climate itself, and whether people are interested in positive action, they should talk about climate things that have happened for longer online if they're interested about them. And that topic of conversation will last longer and take longer to die off. So it's that concept of trying to detect that that's happening, and then thinking like, well, what can we do about this? If people are thinking about this, then perhaps this should happen, just to tip them to be more conscious and stuff. So
I would imagine that there's a bit of an exploratory exercise going on as far as trying to figure out what those systems are. Like you're looking at the electric vehicle stream, right? But is that the right one to focus on as far as the thing that would cause the tipping point? And obviously there's going to be multiple factors. Growth in renewable energy might be another stream that you're looking at, but compared to climate systems, which are probably a little bit more defined, I imagine these kind of factors, some of these streams might die off and they might not even make a difference at all, right? And some of them might emerge, or so.
Yeah, and it's a concept that's like, been talked about for a while, but not from a positive tipping point of view. But it,
Mm-hmm.
like there's been research into, the uptake of vehicles to start with, and it's like, do they fill niches that people need? And so, like there was a certain uptake of cars for people, I don't know, who like needed them for business or something, but then certain cars came out that let people like travel for pleasure and things, and it's filling those niches and things. And so we're on a project now for the next year or so that's trying to work out how to quantify these things and measure them and see if you can see these interactions and put things in place to try and help the climate at the same time. So
Are you also? Do you know if your group is also looking at just how perceptions change from people after they experience, disasters and such? And just anecdotally, for instance, like in Atlantic Canada, there have been some recent hurricanes, and people getting interviewed on the news saying before there were a lot of people who didn't really understand climate change, but I'll tell you now, people do get it and they understand the importance of it, right?
mm-hmm.
And to me, that probably has a huge impact. But are you folks looking at that sort of thing too?
Yeah, well, not necessarily, but it's like depending on the type of data you get, I can kind of imagine that the things I was talking about how people talk about things, online, for example,
Mm-hmm.
that's the sort of thing you might be able to detect. So I can imagine that fitting in the same framework, but it's not necessarily something that we're looking at the moment. So
yeah, very interesting. Positive tipping points. Yeah, I think that's definitely not something that I think people are very familiar with. So really cool that you folks are looking at that.
I guess from our point of view, there's all like this doom and gloom looking for tipping points in the climate, and I feel weird doing it a lot because as a researcher, if you find a result, it's a good thing, but then it means bad things for people. So, it's quite a balance. So the whole positive tipping thing is quite good in a way, because if you do find something, you can be happy about it, like on both ways. So,
well, when I first heard, I'm like, oh, is this just another way of like communicating this, right? But it's more than that, right? Like you folks are actually like, I think there's a good science that can really emerge from that, right? In that, if you really understand when that adoption is going to happen for electric vehicles and the actual impact that'll have on not only reducing emissions, but what that means for the broader climate system or other like there are broader implications for this. But yes, I mean, it's a nice way of communicating this, but it's beyond that. It goes beyond that, right?
Yeah, exactly. Yeah, it's just really complicated as well, because you need to think like even locally for like electric vehicles, is the infrastructure there for people to be able to use them? And
sure.
You asked about Exeter earlier, and perhaps maybe Exeter is getting there, but I can imagine where I live, which is slightly away from Exeter, I can't imagine getting round too well with an electric vehicle, for example, because there's no charging points or anything. So
really?
there's probably some, I've just never noticed them, but
Okay.
I got told that my local council had like a drive to try and work out electric vehicle stuff, but it was a few years after they did it, and I never noticed a change, so I'm not sure how well that went. But
interesting. Yeah, I mean, I feel like there's, even with this current federal government that you have in the UK, there still seems to be an interest on addressing climate. So I would have thought there'd be more advancements on something like EV charging infrastructure in the UK, or at least, I don't know, maybe it's other parts of the UK, just maybe you're not seeing it in your
probably,
Exeter,
yeah, I can imagine in cities, but some ways out where I am, it might be a bit different, but
yeah. You are also looking at, actually, before I ask you go into this other new research that you're getting into, maybe just to end off on the Amazon piece and the work that you folks are doing on understanding climate systems and tipping points. What gives you folks in your group hope, I guess?
I guess personally for me, like I've been working on climate things for maybe like 12 years as an actual researcher after my PhD, and when I used to promote my papers, for example, like a reporter, a researcher also promotes their papers up online, and the kind of feedback you get from those sort of things, it used to get picked up by like climate deniers, and they'd shout quite a lot about, climate alarmism. And I had a paper
Oh.
once where I'd shown that you could look for these early warning signals of the AMOC collapse in a model, and they picked it up and basically said that we were like, pressing the button for the alarm because the world was going to end apparently. And it was like, no, it was just in a model, and it doesn't mean anything. It's just showing that the method works. And now, like this paper that came out last year on the Amazon, I haven't really seen any of that. I've just seen a lot of people perhaps going the other way too much, and almost like climate doomism, which isn't necessarily a good thing, but it means people are interested and they're bothered about the topic. And perhaps had to dial it back a bit and say, like I said to you earlier, no, this is an early warning signal of it happening. But it really shows over that time that people are interested in these topics, and they're really bothered about doing something about it. And that's not something that I noticed like 15 years ago or so. So whether the algorithms have changed and they're only showing me the nice things, but in at least my echo chamber, if that's happening, then I can see that a change in people's personalities, and they are they're coming out on top rather than all the denierism that was there before. So I think the people socially are starting to see that they can make these changes. And you see all these climate rallies and things happening across the world, and I think we're in a much better place socially than we were 15 years ago to do something about it. So
I think about I imagine what's sort of driving that interest on your paper on the Amazon is the politics are so hot there right now, right? It's people are seeing what's happening. There was a whole, remember a few years ago, there was a huge wildfire in the Amazon, and there was so much attention being to the Amazon burning down. And then I remember seeing like, what was it, that there was a cathedral or a church that burned down in France or something like that. And then people, that's it. Sorry, thank you. And obviously that's it. That has a lot of historical and social and cultural relevance. But they're like, we're talking about that, but the Amazon is burning down. It's just just interesting where people's attentions lie. But I imagine that probably had to do something with so much of that interest, right?
Yeah, definitely.
Yeah. Very interesting. Okay, so you're also focused on COVID resilience resiliency in countries. Tell folks about that work.
So this was again, I have to give Tim Lenton the props for coming up with the idea, but we worked on it together. But there's this idea that, again, you can have a system and you perturb it in some way and see how long it takes to return back to normal. A lot of these things you have when you do this, I said about the droughts in the Amazon, but they're different droughts. So you could have a stronger drought or a weaker drought, and COVID gives you a really nice thing to at least measure because COVID and naively would be the same everywhere. If a country gets COVID, it's got COVID. It doesn't get a worse COVID or a weaker COVID. Right. What determines if it's stronger or weaker is how the country's set up to deal with that COVID spike. So in much the same way that we measure the resilience of a system by seeing how long it takes to get back to normality, you can kind of do a similar thing with each country's data on like their COVID spikes and see how long it takes to get that under control. And so we had all these, probably about 180 countries. I think we managed to get decent data on how they've dealt with COVID when it happened in 2020. And so, alongside that, we managed to get lots of data about, societal things. So there's something called the World Value Survey, where they ask people what their views are on certain things, and we picked out certain questions from that, such as how much do they trust their fellow citizens, or how much do they trust their government. We also got things about how stringent their lockdown rules were, and because someone had quantified those, and we basically did this big analysis of trying to link things together, and really strongly it comes up with this idea that how resilient a country is to COVID, how easy it is to get their spike under control and back to normal, is really strongly linked to how much trust is in that country. And colloquially, you can imagine that makes sense. There's this idea of a social contract that you have with your government, where you give up certain freedoms, and and in return you get some kind of safety from them, for example. So I can't go out and lob bricks everywhere through people's windows or something. But I mean, our country's ridiculous, but you can kind of get the idea that in a more trusting society, you're going to trust your fellow country people, that they're going to follow the rules. And if everybody sticks behind something that the government has said, then you get that under control a lot quicker. I mean, in our country, you couldn't even trust our own government with their own lockdown rules. But
Right.
if you look at countries generally, you can see a really nice relationship, that this back to normality happens a lot faster in countries that trusted each other more. So
So this is trust with the government and governing institutions, or even trust, you mentioned trust with people as well.
Yes. So this specific question that came up that people answered was just trust in general, but it is talking about whether they trust each other and whether they trust their government. It was just a whole general question basically, but it's asking that sort of thing just generally. So this specific, this World Value Survey didn't come out just because of COVID. It's something that's totally unrelated to it. So in those countries where I guess New Zealand, for example, where there's probably a lot more trust in their government and their fellow people, they all followed their rules. They got everything under control really quickly, whereas I can't remember exactly who was quite bad. Maybe Russia, I want to say, was quite bad. And they also had low trust. So
makes sense.
Yeah, so they took absolutely ages to recover from their spike, because but obviously the ones in the middle also matched it. So I'm just picking ones out that I remember.
So which countries, just really curious, what are some countries? You said New Zealand stood out as a country that had sort of high trust. What were some of the other countries that you noticed?
I feel weirdly Israel got it down quite quickly, but I think that might have been a vaccine thing as well. But I can't remember
they were
exactly.
Very aggressive on the vaccine thing.
Yeah, but I can't remember if they also trust each other quite well as well. At least according to the World Value Survey. But yeah, I mean, we've got to remember having 180 countries and actually in the paper having plotted out 180 plots and just seeing all these time series, and you kind of go a bit blind. But yeah,
fair enough. So what would you say what's the key takeaway from that research, folks, that you want people to have?
Yeah, so I guess also something we called adaptive stringency, which was a measure of how stringent a country was before compared to what they decided to move it up. So we found a combination between getting adaptive stringency high and also being trusting. They were the most important things for getting this COVID under control. And so perhaps governments could look at this and actually try and be more trusting more outwardly trusting, outwardly facing trusting. So I mean, we really haven't done that in this country very well. I think we've probably gone backwards with the trust according to COVID thing. So I mean, I've seen global news about what our government did during lockdown. I'm sure it's got to you guys as well. But that's the wrong way to go about things. And I can imagine if those value surveys came out now, our trust would be a lot lower. And if we had another lockdown because of some other pandemic that happened, nobody's going to do anything about it, and we'll just all ignore it, and it's not going to get it down. So, I mean. It's a cool concept. It kind of matches in with this kind of resilience work and returning back to equilibrium. And if the government wanted to take something away from it, it's just to actually be more trusting and do what you're gonna say. And it turns out you'll save your your population as well. So
Mm.
it's got a benefit of being nice and being good for people. So
I don't know what the feelings were like in the UK, but I imagine this is probably, I'm going to generalize big time here, but that I feel like in the first few months of COVID, that there was a lot of like maybe goodwill and trust shown by the public towards, governing institutions
hmm
and the people who were, the public health experts, because there was so much unknown and people were willing to like, okay, I'll hunker down. I don't know anything about this, right? And then I want to say by May, June of 2020, all that goodwill was kind of out the window for a lot of people, and you started to see the backlash. But there was something there within those first couple of months that I think people were like, okay, I gotta listen to what the government is saying here.
And I guess in our country it helped that they did this whole furlough scheme where they stopped people going to work, but also paid them like 80% of their wage for not working. So people are quite happy with that. Unless you were one of the people who had to carry on working. But those schemes started to end, and then people were like, well, hang on a minute, I can't go back to work, and I need money, and that's when it also starts to break down, I think. And I guess it's probably like a short-sightedness of how long things are actually going to last. And so like you said at the start, when people are happy, a couple months perhaps, you could live with that. But when it starts moving into a few more months, and we had a really funny thing where we had different tiers of lockdown, like 1, 2, and 3, and like
okay.
So the best tier was, there's no lockdown rules at all.
Yeah.
And people were, people were like, oh, am I going to be in that tier? Like when it got announced tonight. And there was like one little island just off that was like in this top tier where like 10 people live. And, the rest of the country was just in lockdown. And then there was a few countries a few like counties where it's like you're not allowed to leave your house at all. So, everyone thought they were going to be in the good one. And, everyone was in the bad one except for 10 people. So, when you do things like that, that doesn't help trust either, I don't think. So
no, for sure. Before we get into the final two questions, if that's okay with you, just again, real key takeaway from the work, the Amazon paper that you did. What would you want people to take away from that work?
So I think, to reiterate what I said earlier, like the work that we did showed that this was an early warning of approaching a tipping point in the Amazon, and it doesn't necessarily mean that it's too late to stop that. So, any actions that we take now in a positive way towards the Amazon are going to benefit that. And I do feel that, like, if we start to do that soon, then you're going to start to gain this resilience that I've been talking about back into the Amazon, and that could in turn, help us in our fight towards fixing like global climate change. So, I would say, less of the climate doomism and more of the climate action on that point of view, because it's not too late for it. So
wonderful. Chris, are you okay for us to go into the final two questions that I asked every guest?
Sure.
All right, so our first question is our 5 for dinner question. Dead or alive, who are 5 people that you'd want to have supper or have dinner with?
Sure. So, I mean, I've never been asked 5, which is crazy. So it's usually like 3. So I guess I'd start with like Jim Lovelock, a scientist from the UK who he was my supervisor's supervisor. So I don't know if you know a lot about it. Yes, well, like from academic great grandfather, I guess you could say. But there's he passed away last year. He was a really close friend to my supervisor, old Tim. But he's just like this scientist that he had this centenary. He was 100 years a few years ago, and when you learn about all the like the cool stuff he did, and these concepts that he came up with, they're just so varied and stuff. I think that would be a really cool conversation. And I've seen some of that like I've seen Tim talk to him a lot, and I've seen interviews from him, and I think.
But you haven't met him yet. Yeah, you hadn't met him. Sorry, before he
Met him
passed.
from a distance, but yeah, not
Okay.
him.
Yeah.
Yeah. I mean, that was we had a big conference at the university for him, so yeah, he was quite far away, but yeah, that would be cool.
And what was the main focus of, if you could, in 20 seconds or less, what was the main focus of his research, would you say?
Yeah, I guess like the like this concept of Gaia and things and the Earth, how it's like a self-regulating system. It's we're quite big on it in geography in Exeter. I mean, I missed it from a maths point of view because I went up on the other side of academia, but this idea that the Earth self-regulates itself, and and you can look through past records, and and it's a way of thinking about how the Earth interacts with us. And I think we were trying to push Gaia 2.0 at some point by having our specific interactions interact with the Earth, and particularly from a climate change point of view. So setting up these kind of concepts, I think. But he was like an engineer as well, and he's got lots of fun engineering stories and things. So yeah, quite a dabbler, I think. But
yeah, very cool. Number 2, who would that be?
Yeah, I guess I'd go with Sir David Attenborough, maybe, because I guess he's popular over there as well. But so when I was in maths, before doing all the climate stuff, we did have a few like modules on climate, and one of our lecturers was quite proud that he was on one of David Attenborough's like programs talking about climate change. And you start to learn that he is someone who's a really strong advocate for trying to fix the climate problem, but he's also got that that platform to try and inspire that change. So I think that's quite cool as well. So plus he's probably got some really cool stories. So
he's isn't he like 96 or something at this point? I think he's getting up there.
Yeah, it's crazy. Yeah, still doing the stuff though. So
amazing. Yeah, he's just, I think when that time comes, it's definitely somebody the world's gonna miss for sure.
Yeah,
so
definitely.
His voice,
Oh yeah.
Yeah. Number 3, who would that be?
This is so I might be moving slightly more into my hobbies now. So so you might
tell. You're 5,
from,
man.
That's cool. So I'm a huge comic book geek. So
it
would have to be like Stan Lee, who pretty much did all like the Marvel superheroes from like the 60s. So he passed away a few years ago, but he's been at like conventions, and there's the chances to meet him and stuff, and I never got to do that, but I think that would be really cool. And he's like, I mean, I have like 2 Spider-Man tattoos, for example, and stuff like that. So having been able to talk to one of the creators of that, I think would be really good as well. So yeah.
Are you a collector as well of comic books?
Oh yeah, I mean yeah, I've got thousands downstairs. Well, I'm just about to move in a few months' time in with my girlfriend. We're just getting a house together, and she's extremely worried about where all the comics are going to go. So that'll be,
I bet,
that'll be a fun conversation when we get to it. But I'm kind of.
Are you very protective of your comic books in the sense of like, just like, do you have any special ones that you just make sure are like in mint condition? Or...
Yeah. So I mean, you can get them like slabs now. Like they grade them and put them in like a case. So there's companies that do that. So yeah, I've got quite a few. I've got like ones that have been signed, and so yeah, I'm a bit of a nerd, I'm afraid.
Very cool. The Spider-Man tattoo. Oh, my daughter right now is so into. I mean, for kids, they have Spidey. And there's like the Ghost Spider and Spin. She's all into that right now. That's all we play these days. She's almost 5, and we're just role playing Spidey and his amazing friends that's all day, every day. So
I know what you're talking about. So that's okay. I don't know if that's good or bad, but I know what you're talking about. So
I don't know. She sometimes gets really into it. She really believes that she's like Ghost Spider or something, and I just have to. Yeah, you got me and tied me
on the
up.
right track.
Yeah. I don't know if it's going to lead to a life of comic books as well, but yeah, man, thousands. That's you're definitely into it then, for sure.
Yeah, I'm afraid so. Yeah, if she gets into it, make sure you've got the space. So yeah, that's all I'd say.
All right. Good advice. Who else you got? Sorry, forget the first person. What was
Jim
the
Lovelock.
professor name? Okay. And then you have David Attenborough, and then you had the creator of the Marvel comics.
Yeah,
Stan Lee. Okay.
Yeah, so I'm also quite a big football fan, or soccer fan, I guess. So, I grew up in the...
Did you stick your tongue out when you had to say
I
that
did,
right there?
Yeah,
I saw that. That's okay.
So, I mean, apparently we invented the term soccer, so, I can't complain.
Oh, really? I didn't know that.
It comes from... I can't remember exactly. It's to do with because it's association football, so the association bit of the soccer comes from that. So apparently it's our fault that it's called soccer, but I've just pretend it isn't really. So yeah, growing up in the 90s, I guess, I was a big Man U fan of Manchester United. So yeah, definitely their manager at the time would be there, Sir Alex Ferguson. He's definitely got some really interesting stories from the dressing room. I'm pretty sure that there was some boots flying when he was angry and stuff. So, he's still around. He still watches the games and stuff. And I'd like to be hopeful this season, perhaps. But we haven't really hit the heights that we have since he retired. But he's definitely got some fun stories. So
you're still a strong Man U fan then?
I am. Yeah. I'm afraid. Yeah. I also support my local team, but we are four leagues below and not doing very well at the moment. So it's nice to have a bit of success. Supporting as well.
During Ferguson's time, they were fairly successful, hey?
Yeah, very successful. Yeah. So it's changed a bit, but I'm hoping this season we're starting to come back a bit. So
yeah, the whole term about football. I mean, it's interesting. We have the MLS here is kind of taken off a little bit, but even though it's called Major League Soccer, a lot of the teams still call themselves for example, Toronto has a club here and they'll say TFC, which is Toronto Football Club, right? So we still use the term football, even though, so I think I think people understand that a lot more as compared to soccer. So
I mean, I'm a big NFL fan as well, so the football point of view from that, I have to say American football and
sure, yeah, for sure. All right, and then last one, who would be your fifth?
Yeah, I guess personally that would probably be my mum. I guess she passed away about 4 years ago, so the world has really changed a lot in that time. We've had well, I don't even know if Brexit's happened here really, but we've had that happening. We've had COVID, we've had the Russian-Ukraine war, and from a personal point of view as well, I've had the success of this paper, and I'm finally moving house as well. So I think that would be really cool conversation as well. People generally say that sort of thing. So
how did she feel about your comic books?
Less angry than my dad, I think.
Yeah. Thanks for sharing that last one. I appreciate that. No that's a very cool 5. Last question. Besides the circle of life, what do you know for sure?
All right. So I guess this is going to sound kind of advice driven by me, but I've learned that for PhD and these early career researchers, you really, a lot of them I know work all the hours they can, and they'll still be in the office at 10 at night, maybe not even leave, but hopefully this carries through in life in general, that you don't necessarily have to do that. You just have to be productive with your time, and if you kind of structure your day properly, you become a lot more effective. And I think all these people who try and struggle and work all they can, some of the most successful people I know will just work a 9 till 5, and once they're out the door, that's it, and they don't care about what happens until they get into work the next day. And I think that's a really important way to live. And so I think what I know for sure is that just because you work loads, it doesn't necessarily mean you're going to see any success. So
sure, yeah. That's really, I briefly was in academia, and I remember seeing so many of my colleagues working really late and grinding through, and it's such a competitive, cutthroat place sometimes, right? Of having to, especially if you want to be a researcher or want to be a professor, like it's all about publishing in those early days, right? Doing your postdoc, it's all about publishing your papers and and building up that CV and all that sort of thing. So I can understand probably why people put in all that time, but it's very wise what you're saying too.
I think you become more productive if you have that schedule and you make sure that you don't if you burn yourself out, then you're just going to be worse. And having that balance is very important, I think. So
Chris, man, I really appreciate the conversation. I learned a lot about the work that you're doing in the Climate Systems Institute and learning about positive tipping points and even this new work on resiliency in COVID. So thanks for making time for me today, and hopefully you enjoyed yourself as much as I enjoyed the conversation.
Thank you for reaching out. Like I say, it's really nice to be able to talk to people in like different mediums. So you quite often get like academic talks that you have to do, and that can be quite boring. But I'm definitely seeing a lot more public stuff recently, which is fun because you get to engage people who are interested rather than having to be there for academic purposes. So
well, look forward to seeing more of your work in the future, and cool. Thanks again for your time today.
Cheers. Thank you.
All right, take care.
Cool. And you. Thank you. Bye.
All right, thanks everyone for joining us today, and we'll see you in a future episode. Bye.